In the winter of 1942, the Royal Air Force dropped over 3,000 tons of bombs on the French port city of Lorient, targeting the submarine pens where German U-boats returned from Atlantic patrols for repairs and resupply. The raids destroyed much of the city, killed hundreds of French civilians, and reduced the port facilities to rubble. But when reconnaissance aircraft photographed the target after the attacks, the submarine pens remained intact, their massive concrete roofs showing no significant damage, despite direct hits by bombs weighing up to 4,000 pounds. The structure that protected the U-boats was unlike anything the Allies had encountered before. Not a building, but a fortress. Not architecture, but military engineering on a scale that seemed to belong to ancient empires, rather than modern warfare. The Germans called them U-boat bunkers, and they represented one of the most ambitious construction projects of the Second World War. These structures, with walls up to 7 meters thick and roofs that could withstand direct hits from the heaviest bombs in the Allied arsenal, would keep Germany's submarine campaign alive long after conventional bases had been destroyed. They would absorb tens of thousands of tons of explosives without failing. They would require the development of entirely new weapons to penetrate, and they would remain standing decades after the war ended, monuments to what concrete and engineering could accomplish when nations directed unlimited resources toward military construction. The strategic problem that drove the construction of U-boat bunkers was the vulnerability of submarines in port. A U-boat at sea was a formidable weapon, nearly invisible beneath the waves, capable of sinking merchant ships with impunity. But a U-boat in port for repairs was helpless, dependent on facilities that could be destroyed by air attack. German submarine bases in occupied France, Lorient, Saint-Nazaire, Brest, La Rochelle, Bordeaux, were within range of British bombers operating from England. As RAF Bomber Command grew stronger through 1941 and 1942, the threat to submarines in port became acute. Boats could be sunk at their moorings, repair facilities could be demolished, skilled workers could be killed, and the entire submarine campaign could be strangled, not through combat at sea, but through destruction of shore infrastructure. Admiral Karl Dönitz, commanding Germany's submarine force, understood this vulnerability with clarity that came from experience. He had served in U-boats during World War I and remembered how British blockade had eventually defeated Germany, partly by making submarine operations unsustainable. He was determined that history would not repeat, that his U-boats would have protection that no amount of bombing could overcome. His solution was to build shelters so massive, so heavily protected, that conventional bombs could not penetrate them. The German Navy's construction division, the Organisation Todt, would build bunkers in occupied France large enough to house dozens of submarines simultaneously, protected by concrete roofs thick enough to stop any bomb the Allies could drop. The engineering specifications that emerged from these requirements were staggering. The bunkers would be constructed from reinforced concrete, with steel rebar providing tensile strength that pure concrete lacked. The roofs would be at least 3.5 meters thick, later increased to 7 meters when intelligence revealed that British bomb development was producing heavier weapons. The walls would be proportionately massive, designed to withstand near misses and shock waves from weapons detonating nearby. Inside these fortifications would be individual pens where submarines could moor for repairs, workshops equipped with machinery for overhauling engines and electrical systems, storage areas for torpedoes and supplies, crew quarters, and command facilities. The bunkers would be self-contained bases capable of maintaining submarine operations even if the surrounding city was destroyed. The construction effort required resources on an industrial scale. The Lorient bunker complex, completed in stages between 1941 and 1943, consumed over 1 million cubic meters of concrete. Saint-Nazaire's bunker used even more. The aggregate requirements, sand, gravel, crushed stone, had to be transported from quarries across occupied France. Cement production had to be ramped up, diverting capacity from other construction projects. Steel for reinforcement was scarce, rationed for weapons production. Yet millions of tons were allocated to bunker construction because protecting submarines was deemed essential to the war effort. The labor force included German construction workers, conscripted laborers from occupied territories, and prisoners of war forced to build fortifications that would protect weapons used against their own countries. The Organisation Todt, responsible for major military construction throughout occupied Europe, approached the bunker projects with industrial efficiency that characterized German engineering at its best. Construction was planned in meticulous detail, with concrete pours scheduled to allow proper curing, formwork designed for reuse across multiple projects, and quality control procedures that ensured structural integrity. The work proceeded 24 hours per day when materials were available, with multiple shifts rotating through the site. Workers who fell behind schedule faced punishment. Those who met quotas received extra rations. The urgency was palpable and justified. Every day of construction delay was another day that submarines remained vulnerable to air attack. The bunker at Lorient, designated Keroman by the Germans, was built in 3 phases as understanding of Allied bombing capabilities evolved. The first section, Keroman WWII, was completed in 1941 with a roof 3.5 meters thick, considered adequate protection against bombs available at that time. Keroman II followed with similar specifications but larger capacity. Keroman III, completed in 1943, featured a 7-meter roof and became the most heavily protected structure in the complex. Together, the 3 sections could accommodate up to 30 submarines simultaneously, with berths for boats requiring different levels of maintenance and separate facilities for combat-ready vessels preparing to sail. The internal layout of the bunkers reflected the complexity of submarine maintenance operations. Each pen included cranes capable of lifting torpedo tubes for inspection, workshops where diesel engines could be disassembled and rebuilt, electrical shops for servicing battery banks, and machine shops equipped with lathes and milling machines for fabricating replacement parts. Torpedo storage rooms were located in protected areas deep inside the bunker, accessible through corridors that could be sealed if bombs penetrated the outer defenses. Fuel oil tanks were positioned outside the main structure, vulnerable to damage but isolated, so their destruction would not compromise the bunker itself. The Germans had learned from experience that separating critical functions provided redundancy that single-point failures could not eliminate. The first major test of the bunker's protective capabilities came in early 1943, when RAF Bomber Command launched concentrated attacks against the French submarine bases. The raids employed the heaviest weapons available, including 4,000-pound high-capacity bombs designed to demolish buildings through blast effect. Hundreds of aircraft participated, dropping thousands of tons of explosives in attacks that devastated the cities surrounding the bunkers but barely scratched the bunkers themselves. Bombs striking the roofs detonated, creating craters in the concrete surface, but the layered construction absorbed the blast energy without allowing penetration. Even direct hits by multiple weapons in the same location produced only surface damage. The reconnaissance photographs that documented these attacks revealed the futility of conventional bombing against bunker targets. Lorient's city centre was obliterated, its medieval architecture reduced to rubble. Saint-Nazaire's docks were cratered beyond use, but the submarine pens remained operational, their massive structures standing amid destruction, submarines entering and leaving through locked gates that were damaged but quickly repaired. The contrast was stark. Everything around the bunkers could be destroyed, but the bunkers themselves appeared invulnerable. The bomber crews who had risked their lives attacking these targets returned to bases in England with the knowledge that their efforts had achieved nothing except killing French civilians and wasting ordnance. The Allied response to this failure was initially institutional resistance to accepting that strategic bombing had limitations. Air Force commanders argued that larger raids with heavier bombs would eventually succeed, that the cumulative damage from repeated attacks would crack even the thickest concrete, that persistence would triumph where individual raids had failed. Additional attacks were authorized, consuming aircraft, crews, and bombs in efforts that produced the same result: cratered cities, intact bunkers, submarines continuing operations from protected pens. The waste of resources was enormous, but acknowledging that conventional bombing could not destroy the bunkers would require admitting that years of strategic bombing doctrine were flawed. The technical solution to the bunker problem emerged from parallel developments in earthquake bomb design. British engineer Barnes Wallis, famous for his bouncing bombs that had breached German dams in 1943, was working on penetrating weapons that used mass and velocity rather than explosive power to achieve destruction. His tall boy bomb weighed 12,000 pounds, far heavier than any weapon previously used by RAF bombers, and was designed with a streamlined shape that allowed it to achieve supersonic velocity during its fall from high altitude. The weapon would penetrate deep into a target before detonating, creating an earthquake effect that damaged structures through ground shock rather than surface blast. The tall boy's deployment against submarine bunkers began in mid-1944, after specialized Lancaster bombers had been modified to carry these weapons. The results were dramatically different from previous attacks. Tall boys penetrated bunker roofs that had resisted 4,000-pound bombs, detonating inside the structures and causing internal damage that made the pens unusable. The earthquakes created by detonations near the bunkers fractured foundations and created structural failures that weakened walls previously considered impenetrable. For the first time since bunker construction began, German engineers found themselves repairing damage that threatened to compromise the structure's protective capabilities. The introduction of the Grand Slam bomb in early 1945 escalated the technical competition to its ultimate conclusion. This weapon, also designed by Wallis, weighed 22,000 pounds and required specially modified Lancaster bombers flown by elite crews to deliver. Grand Slam bombs created shockwaves so powerful that near misses could collapse bunker walls and internal structures even when direct penetration did not occur. The weapon represented the absolute limit of what piston engine bombers could deliver, a brute force solution that acknowledged defeat of conventional bombing while providing an alternative that finally worked. The Valentin bunker near Bremen represented the pinnacle of German bunker construction and the ultimate futility of the program. This facility was designed as a submarine production plant rather than merely a repair base, capable of assembling Type WWII U-boats in protected workshops that Allied bombers could not reach. The structure consumed over 1.4 million cubic meters of concrete, making it one of the largest reinforced concrete structures ever built. Its roof was designed to withstand tall boy hits, incorporating multiple layers and compartmented construction that would prevent single penetrations from compromising the entire structure. But Valentin was never completed. Allied bombing destroyed the transportation infrastructure needed to deliver components. The labor force was depleted by disease and malnutrition, and the war ended before production could begin. The human cost of bunker construction was measured in workers who died building them and civilians who died in cities that were destroyed attacking them. French laborers, forced to construct fortifications that protected weapons, killing their countrymen, sabotaged when possible, but mostly complied under threat of execution. Prisoners of war worked under conditions that violated Geneva Conventions, inadequately fed and housed, dying from accidents and disease at rates that German authorities neither tracked accurately nor particularly cared about. Allied bomber crews died attacking targets that their bombs could not destroy, their sacrifices achieving nothing except proving what should have been obvious from initial analysis: that concrete 7 meters thick could not be demolished by 4,000-pound bombs. The post-war fate of the bunkers revealed their fundamental indestructibility through conventional means. French authorities attempted demolition of the Saint-Nazaire bunker in the 1950s, using explosives in quantities that would have leveled a city block. The explosions damaged portions of the structure, but could not bring it down. Eventually, demolition efforts were abandoned as too expensive and too dangerous to surrounding areas. The bunkers were repurposed instead. Some became museums, others industrial facilities. Still others simply fenced off as monuments to a war that had required such constructions. All remained standing, their concrete gradually eroding, but their basic structures as sound as the day construction was completed. The Lorient bunker complex serves today as a submarine museum, preserving U-boats and documents that tell the story of the Battle of the Atlantic. Visitors walk through pens where submarines once moored, examining the cranes and workshops that maintained the boats, learning about the men who built the bunkers and the men who attacked them. The roof shows craters from thousands of bomb hits, none of which penetrated to the interior. The structure itself is a museum artifact, physical evidence of what mid-20th century military engineering could accomplish when expense was no obstacle and human cost was not calculated. The engineering legacy of the U-boat bunkers influenced Cold War fortification design, particularly for facilities intended to survive nuclear attack. The principles established in France during World War II, massive concrete protection, layered construction, compartmented design that isolated critical functions, were applied to missile silos, command bunkers, and strategic facilities throughout the nuclear era. The specific techniques evolved, but the fundamental concept remained. If protection matters more than cost, concrete in sufficient thickness can resist almost any conventional weapon. The bunkers proved this, and subsequent generations of military engineers remembered the lesson. The strategic assessment of whether bunker construction justified its enormous cost is complicated and contested. The bunkers protected submarines and allowed U-boat operations to continue after bases would otherwise have been destroyed. But the resources consumed, concrete, steel, labor, might have been used for additional submarines, more anti-aircraft guns, or other weapons with more direct combat value. The bunkers saved submarines, but could not save Germany from defeat. And whether they prolonged the war or merely diverted resources from more productive uses remains debatable. What is certain is that they achieved their immediate purpose, protecting submarines from air attack, even if they could not achieve their ultimate purpose of winning the Battle of the Atlantic. The technological race between bunker construction and bomb development exemplified the broader competition between offense and defense that characterized much of World War II. Germany built bunkers that resisted conventional bombs. Britain developed tall boys that could damage those bunkers. Germany began designing even thicker roofs. Britain developed grand slams that could destroy structures previously thought invulnerable. The cycle would have continued indefinitely had the war lasted longer, with each innovation producing a counter-innovation, neither side achieving permanent advantage. This pattern would repeat throughout the Cold War, with each new weapon system producing defenses designed to counter it, the competition driving technological development at enormous cost, but without decisive resolution. The workers who built the bunkers left little record beyond the structures themselves. Forced laborers and prisoners of war were not permitted to keep diaries or write letters. German construction workers were forbidden to discuss their work for security reasons. The Organisation Todt maintained records that documented materials used and construction progress, but rarely mentioned individuals except when accidents or sabotage required investigation. The anonymous labor of tens of thousands of people produced structures that would outlast their builders by generations, monuments to a war that most of those workers would have preferred never to fight. The bomber crews who attacked the bunkers understood, eventually, that their missions were achieving little beyond demonstrating courage and wasting ordnance. But orders were orders. Intelligence assessments suggested that cumulative damage might eventually succeed, and the institutional momentum of strategic bombing campaigns could not easily be redirected. Crews flew missions they knew were futile because alternatives were not available, and because refusing would have been unthinkable. Their sacrifice was real, even if their effectiveness was minimal, their courage unquestionable, even if their orders were flawed. The contrast between the bunkers' imperviousness and the devastation of the cities around them created images that defined the logic of strategic bombing. Lorient's city centre was destroyed to reach a target that could not be destroyed. Saint-Nazaire's civilian population was killed in efforts to damage structures that resisted the heaviest conventional weapons available. The bombers that could have been attacking industrial targets or supporting ground operations were instead dropping ordnance on concrete that absorbed explosions and remained functional. The resource allocation was defensible only if bunker destruction was believed possible, and that belief persisted long after evidence suggested otherwise. The endurance of the bunkers into the 21st century provides physical connection to a war that ended decades ago. Unlike warships that were scrapped or aircraft that were melted down, the bunkers remain as built, their massive forms dominating waterfronts where they were erected. They are too large to ignore, too expensive to remove, too historically significant to forget. They stand as monuments to engineering excellence applied to destructive purposes, to human labor conscripted for military necessity, to the futility of attacking targets that cannot be destroyed with available weapons. 7 meters of reinforced concrete, 1.4 million cubic meters in a single structure. Bombs that weighed 22,000 pounds, roofs that absorbed direct hits from weapons that could destroy bridges and dams, submarines protected from air attack through fortification rather than concealment. These specifications define the U-boat bunkers, Germany's solution to the vulnerability of submarines in port. The bunkers were concrete battleships, immobile but invulnerable. Structures that redefined what military architecture could achieve and what strategic bombing could destroy. They kept U-boats operational when conventional bases would have been demolished. They consumed resources that Germany could barely spare, but diverted those resources toward protection rather than offense. They survived the war that produced them and remain standing as evidence that some things, once built with sufficient mass and strength, cannot be destroyed by any means short of nuclear weapons. The concrete battleships that sheltered U-boats won their battle, survival, even as Germany lost the war that required their construction.